Welcome to Going In Blind. I'm your host, Zach Tidwell, and my guest today is a nuclear engineer, former submariner, and author. Please welcome Charles Browne. And to everyone at home, thank you for listening. Please take a second to help me grow the show so that I can keep delivering these conversations week after week for years to come. Subscribe, rate, and review the show in whatever podcasting app you're using right now, and check out the show notes to follow me on social media and YouTube as well. When you share your favorite episodes, tag me and use the hashtag GoingInBlind. You can also join my mailing list at zachtidwell.net. And if you know someone you think I should talk to, have them send me an email at contact.goinginblind@gmail.com. All right, Charles, we're here a week late, thanks to me being clumsy, but thanks for making it happen.
No worries. Got to keep Apple's bottom line, in good shape. So
yeah, for everyone at home, right before we were supposed to record last week, I punched a coffee mug right onto my laptop and thought that it was probably better to delay this for a week so this thing could dry out. But just so everyone has a little bit of context here, because you can do a better job of giving a quick rundown of the big touching points of your career, and so people know a little bit about you. Will you just give a quick rundown of your history with the military and then what you've done professionally since, so that people have a little foundation?
Yeah, absolutely. I joined the Navy straight out of high school as an enlisted sailor, and I was selected for the Naval Nuclear Power Program. So I spent the first 14, 16 months in training in nuclear power school and nuclear prototype. And then I served on 3 separate fast attack submarines where I was a propulsion plant operator, throttleman, electrical distribution, etc. After my honorable discharge, I went to work for a commercial nuclear power plant in Michigan, where I was a non-licensed operator for a few years, exercised my GAI bill to earn my nuclear engineering degree.
Attaboy.
And then, with that degree, I was able to earn a senior reactor operator certification, and then ultimately left that utility and went to work for Westinghouse. Just so happens that the plant that I was working at was of a Westinghouse design, combustion engineering technically, but of a Westinghouse design. So they recognized the value that I might be able to bring to them. And that's when I started my project management career. Westinghouse project management, design, and pipeline is extremely robust. So I'm very blessed to have had an extremely rigorous project management background, and then after some pretty successful projects, was selected for their customer first program, which is their Lean Six Sigma kind of customer focused leadership development course and class. And then General Electric kind of took notice. And so, that's like going from Manchester City to Manchester United. I mean, that is a hard sell, but GE had the advantage of being in Wilmington, North Carolina, as opposed to Hartford, Connecticut. And so I moved the family down there and served with General Electric as the operating experience and lessons learned program manager for a new design and a new style of boiling water reactor design. So each of those stints was roughly 7 or 8 years, which seems to be my 7 or 8 year itch.
And then you got to move on.
And so I'm currently serving as the Deputy Director of the Project Management Office for Los Alamos National Laboratory, home of the Manhattan Project and home of our...
And the aliens.
And the aliens, and the home of our nuclear deterrent and monitoring experts. But somewhere along the line there, probably about 10 years ago or so, I did some consulting outside of my day job, and really it created some amazing results for those clients. And so I got the bug to coach and to consult. And so I've been doing that ever since. And one capacity or another, either working for small businesses, medium-sized businesses, project management offices, and then emerging leaders and some C-suite leaders. So I've worn a lot of hats. Obviously, that's the high points and doesn't really get into the real depth of that, but that's okay. That's okay.
Well, and that's honestly, that was I already have about 12 million questions, and I
Nice.
did from the I did from the little email recon that I always do with everybody, but that was definitely that was more wickets than I thought. So
Excellent.
that was
Excellent.
awesome. But as interesting as all that is, psychology's been very interesting to me. And so what the hell propels one to willingly enlist into the Navy to go live on a submarine, dude? Like, and your
Oh,
your tech school was 14 months long?
yeah. I mean, A school, B school, C school pushed a year and a half. Uh,
Holy shit.
yeah, yeah. So that program alone, the first thing they did once I qualified for it was they're like, "Hey, we got to amend your enlistment. If you really want to do this,
Um,
it's 6 years. That's the minimum." Recognizing that first year and a half or so is going to be in training, but obviously it paid off. I definitely would do it all over again. Some of the greatest people, still friends, great mentors. That program was absolutely amazing, and would have been really hard for me to get into, Penn State or NC State to study nuclear engineering just fresh out of high school. Those are very competitive programs. So,
yeah.
enlisting in a program like that is definitely kind of cutting the line. you know, you really do have an express checkout if you do that, if you make that sacrifice.
Well, and when I initially looked into and like was doing my research off of the stuff that you sent over, I assumed that nuclear engineer, I was like, dear God, this dude had to get a PhD or,
I,
but go ahead.
yeah, I don't want to scare anyone away from that program because it's still an active program in the Navy right now, right? We still need nukes.
Yeah.
We're still, aircraft carriers, cruisers, fast attack, and ballistic submarines are all powered by nuclear reactors. So it's a very vibrant and active program. And I don't want to scare anyone off, but it's hard. It's really
Yeah.
hard. And even in, oh my gosh, wow, 18 months of school in the Navy, that's a long time. Yeah, unless you're trying to study 3 years worth of stuff. And then it does not feel like a long time at all. Again, not to scare anyone away, but I mean, I was working 40 hours a week in class, and then the number of hours that it took to study and assimilate and absorb that information in the evenings, we sacrificed a lot.
Well, and that's like the military is incredible at compressing timelines like that. And I mean, it makes the schoolhouses, whether that be your entry level schooling or advanced schools that you go to, just I mean, that's why they're so rigorous and why they are slayers when you go. It's and I was in the infantry, so most of the courses that I went to had a highly physical component of them because you're out doing infantry shit. But even those, dude, like it's just I'm sure those don't hold a candle to the amount of knowledge that you were having to consume, but like they were, it was always like, okay, this is an incredible opportunity that I'm getting to go to, whatever school it was, but my life is about to suck for 14 weeks or however long it was. And you're doing it for over a year. Like
Yeah.
that sounds so miserable, but can you, and I'm not even aware of the differences here. I've heard of fast attack submarines before, and then you just mentioned ballistic. I'm assuming fast attack are the submarines that are meant to take out ships.
Correct. Those are the hunter killers. Yep.
Okay.
Yep. Yep. Ballistic missile submarines have a nuclear payload.
Okay.
They tend to go play hide and seek.
Yeah.
So the cruise and the rotation and the operating tempo are very different. Ballistic missile submarines follow a very strict 90-day rotation. They have two crews, a blue crew and a gold crew. So the blue crew will man the boat, go out, hide, only come to periscope depth every once in a while to check in and get some radio traffic, and then go back to hiding and
Which is
staying
like just
just
barely subsurface for
right.
periscope depth.
Uh, yeah, Google it. I'm not gonna.
Okay.
I'm not gonna quote anything. see,
Yeah, but
see what Jane says.
yeah. All right.
um, and that and they do that for about 90 days, and then they come in and they literally the gold crew high fives at the pier, and then they take it out. So that boat is technically at sea 360 days a year with two different crews, so they kind of split. A fast attack is very, very different. Fast attack goes where it's needed when it's needed. And if you've ever heard anyone in the Navy say that they did a deployment to the North Atlantic, to the Mediterranean, to the South Pacific, those are all operating areas. And there is no set schedule, and there isn't necessarily a set place to go. We kind of chase the action. So it was one crew, and we still spent about 300 days a year at sea. It was a very, again, very demanding position, very demanding role. I'm exaggerating. Anybody who's thinking about enlisting and volunteering for subs, I would definitely talk through that with your instructors and your classmates and stuff. It's not that bad, but it is
I'll
pretty bad.
I'll be straight with everyone listening. Don't volunteer to go on a sub. I, I, dude, I was on ship for 3.5 months of my second deployment, and it was hell. That was only 3.5 months. Like, I really, it gave me, in one respect, or I guess on one hand, more respect for sailors, where I'm like, I don't know how you guys just do this all the time. But also, I was like, what the fuck is wrong with you people?
Yeah,
Like,
yeah.
it just,
The
it, uh,
the sea does not give a shit. That's kind of what you learn right away. It's like the sea does not give a shit about you. It's going to do what it's going to do, and you either learn to accept that and literally roll with those waves, or you could drive yourself insane kind of trying to fight against that and calm the sea. One advantage to submarines is we do go below those waves, and it is very calm, and it is very still and very quiet, once we submerge. So
yeah, I don't even mean the rolling of the ship. And I was on an LHD, so it was huge. But
Mhm.
like, the being, I describe it as prison without the butt rape. That's, I just like,
Okay.
it's, I,
Yeah.
yeah, obviously I'm being facetious in saying that, but like, it's just that I mean, it's part of it's the military is already hurry up and wait, and obviously as an infantryman on a ship, you don't have anything to do. So it's like the fuck games are that's
Yep.
kind of your
Yep.
whole day is either waiting in line for chow, your hour at the gym that you get, or just someone's coming up with creative games to keep people busy, but or
Yep.
going on 10-mile hike around doing laps around the flight deck, which
Yep.
makes no sense. But as you Because when you got out and your degree is a bachelor's degree in nuclear engineering, correct?
Correct.
How freaking rigorous was that program, dude?
Yeah. So the Navy covered most of the math and science. So by the time I was finishing my bachelor's, it was really just calc 1, 2, and 3, differential equations, organic chemistry 1, 2, 3, if I'm not mistaken. So there were still hard classes, but with respect to the core math and physics, that's all covered in the nuclear power school.
And it transferred when you got out.
Yeah, yeah,
Oh, that's
yeah.
huge.
Yeah, it's very
Okay.
huge. But again, I had a very specific agenda when I was even considering enlisting. I took the ASVAB like most guys just to see what would happen, and I scored very well. And so the branches started reaching out. I had an advantage of having 3 older sisters who had, multiple older boyfriends, some of whom had enlisted in various
Oh,
branches. So I was able to ask some questions, right, and
yeah.
figure out what was going on. And at that time, what I didn't want to do, my biggest fear was to enlist and really not get anything out of it, right? My purpose in enlisting wasn't just to say I enlisted or kill a couple of years or, rack up some benefits. I really did want to do the things that you can only do in the military. Okay. You can go ahead and pay somebody $10,000 to do a SEAL weekend or have someone put you through Hell Week. It's not real. You can only do that in the Navy. You can go pay somebody in Vegas to get in a helicopter, and shoot at parked cars, and that's great. But it's all simulated. If you enlist in the military, it's real. Every bit of it is real with real consequences. And so that was a factor. And for me at the time, that's what I was trying to protect. I wanted to make sure that I was going to get out of it everything that I had to put into it. And I visited all. This is what I said. So here's it's going to mess with you a little bit. My father served in the Navy on a fast attack submarine. It happened to be a diesel electric boat out of Groton. And I said, all right, I'm going to take the ASVAB. Oh, I got a really good score. Well, I could probably do anything I want. Cool. Well, I'm definitely not joining the Navy. And I'm definitely not going to be an electrician. And I'm definitely not going to volunteer for submarines, which obviously, you know, spoiler, it's exactly what I did. And the reasons that I did it, though, were not because I wanted to be like my father, but it turns out my dad made some really good choices when he enlisted in 1961. And bit by bit, I went to the branches and they, their position was, yeah, your scores are great. You qualify for all kinds of programs. And I said, okay, cool. How does this work? I sign up and I go to boot camp and then I go to that school? And they're like, well, no, you had a very different experience than I did, right? Which was you go to boot camp and after boot camp, then you sit down with the detailer and we start talking about what your role is going to be in your branch. And I was like, ooh, I don't know that I like that. There's this element of timing in there, right? What if the role that I want or this position that you're describing to me that sounds so great doesn't have any openings when I graduate boot camp, right?
It sounds like you had a shady recruiter.
I had a pretty shady recruiter, or I had three of them, and
nice.
it was also 1988, right? So, there were no contracts, at least for the Air Force, the Marines, and the Army. There were no contracts. It was like, yes, you're absolutely right. You've already met some really great academic requirements. Go to boot camp. Let's make sure that you can handle it. And then after graduation, that's when you sit down with a detailer and look at open billets.
I had no idea that was a thing.
That was a thing in that day.
That's jacked.
I was walking out of the recruiting center and there's Chief Williams leaning up against the door. And he's like, hey, let me just ask you a quick question on your way out. He's like, does, nuclear energy or nuclear power scare you at all? And I said, no. And he's like, we should talk. I know you're looking for something that's kind of guaranteed. He's like, the Navy will write you a contract right now for the nuclear power program, assuming you can pass this entrance exam and you commit to 6 years. And I said, shit. Okay, well, yeah, let's take that nuclear qualification battery test, right? Let me do that. So we went up to Springfield, Massachusetts, and I sat down and took that test. And obviously I qualified, and they said, okay, here's how it works. You pick, you want to be a machinist, an electrician, or electronics technician. And I said, well, shit, I've been apprenticing for my father since I was 5 or 6. I guess I'll be an electrician. I already halfway know that, right? Why would I relearn something new? So there was the Navy and there was the electrician part. And then, when it came time at the end of prototype, which is my last C school, all right, let's target. And I was talking to my instructors and they're like, dude, you need to volunteer for subs. Like your personality, what you do, how intense you are, like you need to be on a submarine. And so remember that.
So it was, you got out of the schoolhouse and then it was then that's when it was decided that you're going to subs. Cause
yeah.
I was wondering like how all of that ties in, because obviously there's the reactor, but they're not going to have a lower enlisted dude servicing a nuclear reactor like while you guys are at sea or something. So okay.
I mean, all the enlisted were the operators. The officers were just supervisors, right?
Wow.
So we had an engineering officer of the watch. So there was one officer in the engine room, and they were in the control room or in the maneuvering, and everybody else was enlisted. We're all operators, right?
Is it all and I don't even know if you're allowed to talk about this. Obviously, you can tell me if you're not, but so like when you guys are at work, right? You're at sea and underway. It's all just computer interfaces basically, and you're reading and managing the reactor through software.
Not in 1989. There was some digital controls, but mostly everything was still analog. You have to remember that this is a war machine, right? And it's got to be battle hardened. And at that time in the 70s, I mean, the boats that I served on, 688 class, you can look it up. I don't know when the Los Angeles 688 was commissioned, but I was on the Baton Rouge 689. So I'm pretty confident these are the first generation of Los Angeles class submarines, which means they were designed in the 60s, built in the 70s. commissioned in the late
And
70s and then put into
jeez.
service. So these boats are tough. I mean, tough. And the way that we did that is we understood analog controls and analog uh, monitoring, right? So it was basically World War II technology. So,
Except a nuclear reactor.
well, but even that is still, 1940s, 1950s technology.
Yeah, but was that rolled into? I mean, we were just now starting to understand those things back then, correct?
And yet the USS Nautilus went put to sea in 1954 or 19 whatever.
Really?
Yeah.
Oh my gosh, dude, that's
Oh
like
yeah. Yeah, yeah.
cavemen playing with.
No, that was
Wow.
yeah, that was Admiral Rickover. Listen, the premise behind any kind of propulsion system, right, is so let's work from the back of the boat, like toward the you have a propeller, right, a screw, and it rotates in the water. Okay, fine, cool. That mechanical energy is transferred through the shaft. That shaft is connected to a set of gears. Those gears are connected to a set or a single steam turbine. Okay, so it's steam that actually propels the boat or the ship. What makes steam is heat. So old boats, diesel boats, not diesel submarines, they operate a little bit differently, but effectively, if you have a steam trawler, old school, you know, Queen Mary, Titanic type stuff, they had a boiler. They were burning coal to create that heat to boil water to generate steam to push the boat. A nuclear reactor just does that without any exhaust gas. Nuclear reactors gave us the capacity and the capability to take that kind of power and sink it and put it underwater because we don't have to exhaust any combustion gas, right? Old boats, diesel electric boats, work on a different premise. The diesel generator on a diesel submarine charges a battery. And then you turn off that diesel, close that exhaust port, submerge the boat, and now you're running off an electric motor that's doing what I just described
Oh,
through a set of reduction gears and a screw. And
that's what I'd assumed the nuclear ones were doing, was that it was a battery. It's steam. Wow.
yeah.
That is so crazy to think back in the 50s,
Oh
dude.
yeah. Yeah. They were ballsy.
And probably didn't fully understand like radiation shielding and stuff.
Oh
Yeah.
no, absolutely. Oh no, no, absolutely, absolutely. One of the differences between U.S. boats and Russian boats is the U.S. pays a lot more attention to personal safety than Russia does. So the shielding and the emergency equipment, it's very, very focused on protecting human life. And so operationally, again, I'm not going to speak to operational envelopes, but operationally, limitations that we put on US boats are in an effort to protect the crew, you know? So you can strip out, you can take out the roll bar, you could take out the bumpers, you can take out the ABS. It'd be a lot faster, right? A lot lighter, but it would also be a lot more hazardous to be in should anything go wrong. US
Yeah.
boats are basically Volvos underwater,
You just
right?
know they're going to keep trucking and the whole
Absolutely.
family is going to be safe no matter what happens.
Absolutely.
Yeah.
That's the goal. Unfortunately we've lost a few boats, but
I mean, it seems inevitable that that would happen, shoving a tube way, way down under the sea. I mean, that's
yeah.
still the premise of that is still wild to me that that's even possible that we do that. I mean, obviously we've been to space, so that's not that crazy, but it's just, oh my gosh, dude.
Yeah. You want to read a really great book specifically about that era. Read Blind Man's Bluff. It's a story about the submarine force, and it kind of starts at World War II and goes through the Cold War.
Okay.
Because as you can imagine, the role specifically of a submarine changed significantly after World War II and into the Cold War. It's a fantastic book.
Okay. Yeah, I'll have to check it out. So fast forward, you've got jumping back. Sorry about the timeline backwards to bring it back forwards again. But you, I guess, I mean, it's a ton of math. Is a lot of the work as an undergrad nuclear engineer, I mean, is it all of that math? Are you doing theoretical? Are you literally engineering structures to or plants,
Yeah.
or
Yeah.
that's what it is?
So there's a few different ways, and I want to make a careful distinction, which is nuclear engineering is not nuclear physics. I had to take nuclear physics classes as a part of my nuclear engineering degree, but not a nuclear physicist. I don't mess around with theoretical physics and do experiments to see, how many neutrons ricocheted off. I'm, as a nuclear engineer, it's very practical. And the focus of that engineering degree is how do you harness that power safely? So we can definitely have a 101 class on nuclear energy and nuclear power production. But a nuclear engineering degree is really about, okay, how do you control fission? Fission produces that heat. How do you channel that heat? How do you do that safely? What are the myriad systems that you need to harness that power safely? And what do you do if something goes wrong? So there's, several hundred, maybe a couple thousand, maybe a couple thousand operating in the country right now like that, of those, of people like me. Um, we only have 120-ish nuclear, commercial nuclear power plants in the country right now that are operating. A couple are being, licenses are being extended. So, we're looking
And
at, yeah.
y you mentioned fission. I know there's been talks of nuclear fusion. Is that I know that, to my understanding, that's none of that has been, like, rolled out into production. So would that process is still more so physicists than engineers, or
Yeah,
okay.
yeah, yeah. And so yeah, that bridge between theoretical, they do experiments. You still need watch a little Big Bang Theory. You know what I mean? Those guys kind of make jokes about it, but theoretical physicists do the math and they postulate what is possible, and then they hand it over to engineers and say, "See if you can make this. See if we can do this." And so even here at Los Alamos, there's experiments like that going on all the time.
Yeah.
We do that type of work all the time. Fusion is definitely an emerging technology. I am not a fusion expert, but I do know that we have been making strides in maintaining a plasma field just longer and longer and longer and longer. And there's several facilities around the world that are trying to do that, because if we can master fusion, it really is just like you see in the movies. It is unlimited and it is essentially free. So it really has some pretty powerful implications.
Do you have any I know this is these out there questions are dangerous, but any sort of is there any talk in that field of a timeline to when we think that would actually be something that is commercially, or not even commercial, just viable in an actual production environment?
Yeah, it's kind of funny. All of that work stalled out because we hit some pretty specific and significant obstacles. It's actually the emergence of AI that has created breakthroughs in some of those fields, specifically in material science. I mean, these are fusion reactors burn hotter than the sun, hotter than the sun. That's how hot these are. So we couldn't even imagine what materials would be able to manage that. We had to use a ton of fusion. In particular, uses very very strong magnetic fields to control that. So there's been quite a significant leap forward in fusion technology, thanks to being able to, just the processing power of AI and the problem solving that AI can do for us.
And when you're saying AI, you are these LLMs, or is this a different subsect of AI that you're talking about?
Oh yeah. Well, I mean, we could call it an agent, right? So it definitely be a large language model. All the research facilities that I know of have their own. They're not
Okay.
they're not putting that stuff into chat.
Into ChatGPT, yeah.
It tends to be a couple firewalls around some of that technology that we don't necessarily want to openly share.
Yeah.
Yeah, yeah,
Nor do you want ChatGPT hallucinating like it does with everything
right,
else. Yeah.
right.
Wow, that's I guess. And is Los Alamos is, I mean, it's a research facility. Is that just all government funding, or is some of that private stuff that you guys are doing?
I mean, for all intents and purposes, it's all Department of Energy.
Oh, okay.
There are avenues to use national laboratory resources for private companies. There's a couple ways to do that, but you do that through the Department of Energy, Department of Homeland Security, Department of Defense, that type of thing.
Mhm. Do you, I mean, this is something I think this is wild when, and I think I understand why. Probably it's, I'm sure there's a lot of factors into why nuclear energy isn't as prevalent as I think it should be. But in this green energy discussion, no, like nuclear just gets ignored. And I think some of that's,
Yeah,
there's
yeah,
huge industry in the traditional green energies that we talk about, and they're subsidized, and they're obviously, then there's lobbyists and all sorts of things. And but this fear that people have of nuclear meltdowns and nuclear incidents seems to be left over from older generations of reactors. Can you speak to, I guess, safety today and the actual feasibility of action outside of legislation and jumping through red tape and stuff like that? Like, is nuclear energy a viable option for producing energy on large scales? I mean, we're seeing these AI companies are talking about spinning up small reactors just to power their data centers. And
yep,
so
yep.
obviously if the will is there, we can do it. And so it's not that dangerous if that's being allowed to move forward. But can you kind of break some of that down for people listening?
Yeah, absolutely. So anyone listening is automatically going to assume, and probably rightfully so, that I'm pro nuclear. Obviously, I built an incredible career working with amazing people, and I can promise every single solitary one of you, never ever once in the middle of the night did we load up 55-gallon drums of nuclear waste and pour it into your river. That never happens. In fact, so if you're anti-nuclear, you're not going to hear anything I'm about to say. But for those of you who are on the fence or agnostic about nuclear, this is the God's honest truth about commercial nuclear power, and even government nuclear power in the United States. We can track every single solitary gram of waste that we have generated since the beginning of the nuclear power program. Okay, every single gram. And here's a statistic that's going to blow your effing mind, which is if we took all the waste from every commercial nuclear power plant in the country and put it all in one place, it would fit on a football field.
I'm so glad you brought that up because I've heard that before and I wanted to ask you about that.
That's insane. Do you have
Yeah.
any idea? Like, I don't have the statistics right off the top of my head because I don't go to schools and stuff like that anymore. But if you really want to Google something, look at the power density of uranium compared to gasoline, coal, natural gas. The power density is absurd. You know, not it's not gonna okay. Um, Fuel, uranium oxide is what fuels a commercial nuclear power plant, right? Before it's irradiated, you don't necessarily want to hold it and lick it, but it's not, you can be in the same, we have to produce this stuff. We have to manufacture this stuff. So until it's irradiated by its first field, its first neutron field, until that fuel pellet starts to fission, we transport. I mean, we transport it around the country, put on backs of trucks. We drive it from manufacturing facilities to nuclear power plants. I mean, it's not dangerous until it's been in a reactor and exposed to a neutron field, and it starts to fission and it starts to decay. Um,
And
so
so is that
Mhm.
you guys literally create an environment with excess neutrons so that it causes them to shed neutrons and create these isotopes? Is that how that works?
Yeah, if I kind of think of it like a cascade, right? So, you ping a uranium molecule with a neutron, a thermal neutron, and it fissions, right? Which statistically astronomically hard to do. Okay. So you literally have to bombard millions upon billions of neutrons to get this to start to happen. But once it happens, a successful fission then creates, on average, 2.43 more neutrons. And those 2.43 go forward, and some of them fission and some of them don't. Some of them leak out, some of them get absorbed by, other materials besides uranium. And that's what creates this cascade of, fission, and why it becomes and how it becomes self-sustaining.
And then you're managing that chain reaction.
Exactly. So temperature is a way to do that. Colder water is denser. It thermalizes more neutrons. It slows neutrons down. At the moment of fission, those are fast neutrons. When they travel through water and they impact water molecules, they lose some energy and they slow down.
So
And
are
they,
you
s- Mhm.
are you submerging the uranium oxide in water?
That's the key to safe fission, is you
Okay.
must keep that core covered with
And
water
then
at
you're
all times.
managing the
Right.
temperature of the water.
Right. So when
Okay.
you hear the word meltdown, what happens is the fuel becomes uncovered. There is no moderator, so water or salt, whatever the uh, absorption medium is. you know, I'm trying to figure out a way to explain. If you put a teapot on the stove full of water and it heats up that water and the water starts to boil, that you'll reach 212 degrees in that kettle and it'll stay 212 degrees until that last drop of water evaporates. And then that teapot will turn red, right?
Yeah.
So you got to think about that metal teapot like a fuel assembly inside a reactor. As long as it's covered with water, the heat is being transferred from that fuel cell to the water, and the water is moving. Okay, it's the teapot's kind of a bad example because the water in a reactor is moving. It's coming into the bottom of the reactor, kind of cold, and then it's traveling all through all these channels, getting heated up and cooling the fuel. So by heating the water, you're removing removing heat from the fuel cells. The water heats up, it rises through that vessel and then exits the top of the vessel hotter than when it came in. That's a heat exchanger. That's all that is.
It's crazy. I've known that water is used to maintain or
Mhm.
control the temperature of these reactors. I always thought it was like how they use them in computers, where it was like just running through the infrastructure, not actually around the fuel. That
Right.
is
Right.
so interesting,
Yeah.
dude.
Big. Let's go ahead and dispel a couple of more, rumors and stuff like that about nuclear as well. That water is in the primary system, right? It's touching fuel assemblies. It is very radioactive. Okay. But it's also filtered and cleaned and maintained, and it is a closed loop. That water, it gets cooled and condensed in a steam generator. It gets injected back into the core. It gets heated up, comes out of the core. It is turned to steam in the steam generator, or it's hot water into the tubes of the steam generator, and it boils water in the steam generator. But that water just circulates from the steam generator to the reactor, to the steam generator to the reactor, through reactor coolant pumps, all that kind of stuff. But it's a closed system. We have some losses. If it were through any kind of leakage, it would be contained inside the reactor compartment. Okay, it's not running down the street. Um, when people see those huge conical cooling towers and they see water coming out of there, come on, man, that's not radioactive. Like, get over it. It is not. That is fresh water that comes in to cool and condense the water that just went through the turbines, right? We talked about the turbines on the submarine. That it spins that's a completely different system, completely separated. They do not touch. That water's clean. That water's clean. I mean, it's got chemicals in it so that it doesn't corrode the metal and stuff like that. I wouldn't drink it.
But yeah, but it didn't just run through the reactor.
Right. So when you see that water coming out of the towers, that's literally water being, hot water coming into the top of that tower and then being run over baffles so that it breaks up into little tiny droplets and it cools off. And then all the drops, some of that condenses at the bottom of that tower and it's reused, and some of it evaporates off. So
Gosh, it's so I'm still kind of, my mind is boggled that this whole time, like I've been thinking the water was just running through like tubes in the system and not around the fuel. That is
Oh yeah,
so,
no, 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 no. You got to keep the
so
fuel covered.
wild.
there's
And go ahead.
there's a couple different designs, and so anybody who is familiar with nuclear power that's listening to this, I've been talking about pressurized water reactors, not boiling water reactors, which is a very different design. Effectively the same principle of operation, but just executed in a slightly different way. So those of you who are mad at me for not talking about BWRs, I'm sorry.
Well, and because I know you had talked about, I think it was might have been the first company that you mentioned you worked for. They were actually working with combustion engines, right?
Well, combustion engine was the name of the company that designed the reactor for the plant that I worked at, and Westinghouse bought them out. So it was
That is so confusing.
yeah, it was designed well again in the heyday, right in the 60s and 70s when it was like, let's build a bunch of nuclear reactors. We're going to fuel the, we're going to power the whole country. Everything was
Oh,
going great until 1979, and 3 Mile Island happened, and then everybody went, we're not building any more of these.
yeah.
And I mean, there was a release, but not nothing, nothing. Nobody was hurt. Nobody was exposed to ridiculous amounts of radiation. I mean, there's horrible incidents. Don't get me wrong. Fukushima was a mess. Chernobyl was an absolute mess. They have Fukushima has a similar design to what the U.S. uses, but Chernobyl is a completely different design. And again,
Soviet era.
no offense to the Russians, but yeah, they were all about let's just get it done. And they used, this is going to get super technical. They use a positive temperature coefficient of reactivity. So when I briefly explained when water's colder, it thermalizes more neutrons, right? As the temperature goes up, it thermalizes less neutrons, which makes our reactors inherently safe. As the temperature starts to go up, if that were go up at a crazy rate that we
It's
couldn't
bleeding
control,
off more neutrons.
it's not creating as many. Yeah, so fast neutrons are leaking, which means less fissions, which means it self-regulates. It gets to a temperature where it's no longer thermalizing neutrons for fission, and the reactor effectively slows down. The Soviet design was completely different. Positive temperature coefficient of reactivity, which means the hotter it got, the more neutrons they had for fission. So as the temperature started to rise and go out of control at Chernobyl because of some equipment failures and some equipment misalignments, that shit melted down like crazy.
Yeah, I read a book. I guess it's been, I think it had to have been like 5.5 years ago, but it was on, and I wish I remembered the name of it, but it was about Chernobyl and specifically like how it was handled as it was melting down. And like they were basically just throwing bodies into this.
Yep, yep, yep,
Oh my, it's horrendous. And
yep.
I mean, it sounds like something out of a bad movie about if you wanted to terrify people about nuclear energy, like that's how you
Yeah.
used to.
Yeah.
But
Everybody keeps asking me, "Hey, did you watch Chernobyl on HBO?" And it's like, no. For the same reason that I will not watch a submarine movie. Like, no, the technical inaccuracies will make me throw shit at my TV. Like, I can't do it. I understand that it's technically for entertainment. It's not an instructional video, but I just refuse to watch it because it perpetuates so many horrible stereotypes that I can't even watch that shit. So,
yeah, they're tropes
yeah,
associated
yeah.
with nuclear. But with, and the random question that I was thinking about when I think when you were just discussing some of the heat exchange stuff. What is it? I feel like I think it's graphite. How what role is it? Aren't
Yeah.
graph isn't what
Yep.
role does
Yep.
the graphite play?
We do. There's a couple different moderators, right? So what I just described, water's a great moderator because it's cheap, it's plentiful, but it has limitations. Some of which are it boils, and it tends to boil away and
Yeah.
cause air pockets and expose fuel. Graphene reactors and molten salt reactors kind of address that. They're just a different moderator. So instead
Mm,
of water circulating over the fuel, you have a different moderator that has different properties, and there's pros and cons. They're more expensive, they're whatever. It's harder to do, but there are some advantages to those.
okay. So as you've worked with these other companies, I mean, is some of this stuff, have you been assisting in building out facilities or
Uh,
just along
yeah.
this timeline, what does this work look like?
When I worked for Westinghouse, they were designing the AP 1000 reactor, which is a 1,000 megawatt reactor. They had an initial contract to sell, I don't even know how many, 12 or 18 to China. And that's great. The Chinese were willing to give Westinghouse quite a bit of money for development and design, and I was the project manager for the reactor protection system. So I was responsible for building out, again, engineers design those entire instrumentation and control communication systems, and then my project team built the first prototype and then built the first production unit. And then that production unit was exposed to a ton of testing. EMC, thermal, the whole bit, the shake table, right? So is this thing going to work before, during, and after an event? And there's,
Stress testing it.
yeah, exactly. So, yeah, that was the biggest project I did at Westinghouse. The others were, since I was licensed on that combustion engineering design, there's several other units in the country that were combustion engineering design. So I went and did a lot of work in maintaining those plants and helping them deal with the obsolescence of equipment. Like the submarines that we talked about, a lot of those plants were designed, in the 60s, built in the 70s. So there was a lot of analog equipment that was just no longer being made. It just didn't exist. So how do you keep that plant operating when its original equipment is no longer available? And how you do
Oh,
that is you figure out, right? And so there was a lot of retrofitting of new digital technologies. Didn't necessarily make a big impact, except that I will say, very proud of my predecessors for being extremely conservative in their calculations and in their margins for operating these plants. Because when you see, oh my gosh, the reactor up the road from me was only licensed for 20 years. It was supposed to shut down in 99, and now it's 2025. They're going to kill us all. And the truth is, the reason it was only licensed for 20 years is because there was no precedence. We had no idea. We know that, a neutron flux, that field of neutrons, when it interacts with metal, it makes that metal brittle. So we know that ultimately the components in the reactor are being exposed to a neutron flux. They're going to get embrittled. Well, okay, eventually they become so brittle that we shouldn't use them. They're not safe. So they ran some
mm.
calculations and said, conservatively, if we ran at 100% wide open, somewhere around 20 years, now we start to get to this place where we think there's a 50-50. So they license them for 20 years conservatively. Great. That's a really good idea. Somewhere, obviously we're continuously monitoring those components, that metal, all those things. And what we were finding is, they were super conservative. We're not seeing the embrittlement that we thought. We're not seeing the breakdown that we thought. These plants are incredibly robust. And, we haven't even really talked about the human element. The biggest thing that came out of the 3 Mile Island incident was just the change in the way we operate. And human performance is absolutely huge. Again, it's a big reason why I got into coaching and consulting. You talked about psychology a little bit earlier. The mindset of who you have to be able to focus and do what you're supposed to do and verify that that is manual valve circuit water 371, not manual valve circuit water 317, right? Those little mistakes are what cause problems. They stack up and they create events. So that whole side of the human performance is really, I mean, I started that when I was 18 years old, exposure to that human performance side of things.
On attention to detail. The
Absolutely.
military ingrains that into people. And I think that's something that I think even we probably underappreciate getting out because that was your formative years when you were, that was just ground into you. But it kind of teaches you how to think about things in a very
Yeah.
basic sense, but in a more yes, analytical, but I feel like because there's so many processes in the military with everything, there is a process that it does
Right.
teach you to think through things like that as well outside of that space.
Yeah, absolutely. And just knowing yourself. What triggers me? What distracts me? What are my values? What are my needs? When do I feel like I don't want to be here? What is it about that really learning and understanding yourself is extremely powerful. And obviously it's not limited to the nuclear industry, right? Thank God pilots have that. Thank God doctors have that attention to detail and that ability to focus and control and regulate their own nervous system and their own mental state, right?
Yeah, it's being aware and knowing what to be aware of, I think is the other half of that, right? Like
Hmm.
you have
Hmm.
to know what you are actually needing to draw your mind to. But what is it before we move along here? What is it about the neutron flux that makes the metal brittle?
Well, those neutrons impact the molecules of the metal,
So it's just
right? It's
bombarding it.
just, you got to think about those neutrons just tearing us through
Uh,
that metal. It breaks down the lattice structure.
I mean, is that one of the things that's being researched material wise? I know we were talking about fusion specifically earlier, but
Yeah.
we could come up with metals that could withstand that kind of stuff.
I mean, the metals that we're using right now are doing pretty flipping good. I mean, they really
Okay.
are. They're doing pretty well. There's a trade off there, right? I mean, you could create an infinite life cycle material, but the cost would be
The cost.
astronomical,
Yeah.
right? And uh, nobody's going to put production above safety, at least not in that industry. But you do have to make a profit, or we can't afford to build the damn thing, right? So there's an argument there where, hey, Inconel is a great material, stainless steel is a great material. Let's just use it and monitor it, and that's what you do as a operator. That's what you do as a nuclear engineer. That's what you do as a regulator within the Nuclear Regulatory Commission. That's what you do is this operating the way it was licensed to be operated? And if you boil this down to a car, you go buy a used car. What do you want to know? What do you want to know? Show me the maintenance records. Show me, what kind of asshole are you? Like, did you drive this thing 0 to 100 from stop sign to stop sign, or how do you drive this thing? And so when any plant in this country is licensed for operation, you get a very, very strict set of operating instructions. You will not heat up faster than this. You will not cool down faster than this. You will not exceed this power level. You will not do this. You will not do that. You will not have this piece of equipment and this piece of equipment out of commission at the same time. Like, you will not do that because it compromises the public safety.
Which is, I'm so glad that we got into that because that's again, if you are listening to this, which if someone is like just vehemently anti-nuclear, they're probably not still listening at this point. But that's that someone needs to clip that and put that out there. But I mean, it is, and another thing, coming back to the profitability of these things, another way to achieve that is through scale and getting more of them out there.
Well, actually, it's actually more counterintuitive than that
Really,
because, so I talked about the AP 1000, and yeah, 60s, 70s, and 80s, that was the thought, right? The way that you generate revenue from a the reason nuclear power plants are so profitable, like they are ridiculously profitable. They're expensive. They take a long time. Yes, 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 yes. But they are insanely profitable because you turn that thing on, you ramp it up to 100% power, and it runs that way for a year and a half or 2 years, nonstop. And then you shut it down for 30 or 45 days to refuel, and you start it back up and you run it for another year and a half or 2 years. So that is, on average, whatever, right? There's a range, but 600 to 1100 megawatts all day, every day, rain or shine. These plants just run. So the argument financially was bigger plant, bigger plant, bigger plant, bigger plant, more megawatts, more megawatts, more megawatts. And what happens is there's an inflection point there where the plant becomes so large that it becomes incredibly difficult to build and maintain. So what's happening in the industry now, you spoke a bit very early, small modular reactors, SMRs, brilliant. TerraPower doing amazing things. There's a bunch of companies that really want to build these small modular reactors that serve a community. They don't have to power an entire city. They can serve one part of the city. And what you do is you end up modeling the internet. Instead of having one node, one source, and when anything happens to it, it becomes a single point failure, stresses the grid, overloads adjacent power sources and adjacent reactors. It's like you take 1,000 megawatts off the grid instantaneously because of a trip or something like that. Holy shit, that really stresses the system. But if you put little 100 megawatt reactors all over the place, they don't operate the way that I just described. There aren't operators coming in and out. There isn't a parking lot. There aren't buildings. Right? They're small, some of which are designed to be buried, taken critical, and left there. They're self-regulating. They're self-cooling. They're incredibly safe. That is absolutely what's going to power our trip into space. I'll tell you that right now, is that type of technology. What it'll look like, I don't know. I'm not on that side of the world. But so the idea of actually, instead of building giant plants that require immense amount of resources, that's a lot of water. It's a lot of gallons per minute to cool that equipment. They're huge pumps, huge equipment, a lot of operators, a lot of training, a lot of stuff. It's expensive. So there's this not exponential, but there's this asymptotic approach to, we're getting thinner and thinner margins. We're not getting higher margins because the cost of O&M exceeds the cost of what's on the grid. So we're going the other way with it. The industry's going the other way and making much smaller reactors. And then you create this network, this web of power. And if 1, 2, 3, 4, 20 go offline, you don't even notice. You don't even notice.
Yeah, and I that's what I meant. I was more, not bigger, and
Oh, right. Gotcha.
but
Yep.
I just probably could have used a better word than scale there, like scaling out instead of scaling up. But and
Uh-huh.
that is, I'm curious. I mean, if you follow that train of thought with them getting smaller, because I didn't even think about them getting smaller and smaller. I was just like, oh, we get more plants around. Do you eventually could you see a world where it's okay, that's how a plane is, there's reactors small enough to be on a plane or in a car.
Um, I don't know about that. I don't know about that.
It's
I
too
would imagine.
sci-fi.
Yeah, no, I mean, listen, the satellites that we send. I mean, this is something that Los Alamos does. They're powered through radioactive decay. Radioactive decay creates a couple of things: either heat or static, electric. It's a little bit harder to explain, but it's literally those satellites that we send to the end of the solar system and out into the universe. They have a nuclear power source.
It's fission.
No,
Oh,
not the
okay.
way, not that we explained it, because we want to convert fission, the heat of fission, into mechanical energy in a turbine to
Oh, okay.
generate electricity. This is a bit more direct and on a
Wow.
much smaller scale. And there's nobody in that satellite. So we're not too worried about any other radioactive fields or any other emissions from that device. We're not care. We don't have to worry about personal safety.
Yeah.
There are reactor designs that fit in a tractor trailer. It's just a matter of how much fuel you want to load into there, how big the core is, and then how big the supporting equipment needs to be, because that cycle doesn't change. Go to YouTube and look up a videos. How does a nuclear reactor work? How does a generating station work? And they'll show you a cool little animation of this goes this and this and this and this. You can scale that up, scale that down as much as you want. The trade-off becomes, well, what's the feasibility of it? Like, what am I going to do with a 50 megawatt reactor? A freaking lot. FEMA FEMA would love 50 megawatt reactors on the back of a tractor trailer. Are you kidding me? Absolutely. And if you look, a submarine isn't that far off. Again, look and see what's publicly available with respect to dimensions and sizes and capacities. I'm not going to quote those here, but
Yeah.
look that stuff up, and it's like, oh, actually, that's a little different than I thought.
Yeah, I mean, I never even would have thought of the idea of like in the back of a tractor trailer. That is such an
Yeah, you
really
pull.
would be a paradigm like shifting concept
Yeah.
for like disaster relief like that would
Yep.
be huge.
Yeah. All you would need is a water source, right, for external cooling of some of that equipment. Depending actually on the design, there's ways to get away with that with heat sinks and with some other equipment breakthroughs. But ultimately, yeah, I mean, you hook that thing up to a 4-inch fire hose and you're chugging away, or hook it up to a pump. You know what I mean? That's drawing off of a water source somewhere.
That is so, and now I'm realizing I'm almost at the point, like down this thread that like I don't know what to ask, but I'm curious, is there something, I guess, in this field that is coming to prominence or that has you excited about it right now that is in the way of innovation in the field?
I've always loved the idea of SMRs, of small modular reactors.
Okay.
I wouldn't hesitate for a second. As soon as that becomes licensed and the utilities start to come around, like the oil drillers used to come around and say, "Hey, we'd like to lease your yard. We'd like to lease your property, and we're going to pay you every time we hit oil." I would have said yes immediately. I mean, that's horrible. I know it's not great for the environment, but stuff like. But that's going to be the equivalent of, "Hey, we'd like to lease your backyard and bury a reactor back here for your neighborhood." Yup. Yup. Go right ahead. And I'm gonna put my pool over the top of it and it'll stay
Have a
nice and
heated
warm. No, I'm
pool.
just kidding. I'm just kidding. I'm just kidding. But but I'm just I know what the design, testing, and licensing process is. If the Nuclear Regulatory Commission and the industry has blessed off on a design, I'm in. I'm in because the nuclear power industry it's kind of a trip, right? Because obviously, Florida Power and Light is in competition with Duke Power, is in competition with Progress Energy, is in competition. Right? Technically, they're all vying for the same customers, and they will all want to sell as much electricity as possible. Now, thankfully, we're still in a gold rush. We never seem to be able to catch up with electrical demand, and so there's always a buyer. But even with that, I mean, in that way, it kind of reduces the stress of competition. We all have buyers, but it does help to regulate the costs. You know what I mean? You
Yeah.
can't, nobody has a monopoly. You're not going to run up electrical prices to be ridiculous. But one of the things that I've always loved about that industry is they're open books. I don't care if we're direct competitors on the grid or in the stock exchange or in the commodities market. I don't care about that. How did you learn how to do that? How were you guys able to do that work in that amount of time? What
So
is
they
this new
shared the
design?
knowledge?
Absolutely.
Oh,
Benchmarking is a way of life. So the industry is very open and at the same time, very protective. I know that it does not matter what utility you work for. If one of those facilities has a problem, we all pay. Every nuclear power plant has to shut down, right? Everyone, when Fukushima went, we were all kind of wringing our fingers like, oh my gosh, are they going to make us shut down? Are they going to make us all shut down until they fully understand what happened at Fukushima? Because when you don't know what happened, you have to assume conservatively that this is a flaw that exists in every plant of the same design. And if that's the case, they all need to be shut down until we understand that flaw and we correct it.
yeah.
That happens. And politically, it's again, it doesn't matter whether it's a BWR or PWR, whether it's in Michigan or in Florida or in Texas, it doesn't matter. If there's an issue with a nuclear power plant, everybody gets called to the carpet and everybody's jobs are in jeopardy. So we are very protective of the industry. And so we hold each other to a very high standard. So we don't put up with bullshit. So somebody comes up, with a crazy design, like, oh yeah, I'm going to do this, and I think it's a good idea, and this engineer that I'm paying $350,000 a year thinks it's a good idea too, so we're going into production. Oh
Everyone's like,
bullshit!
chill out.
Yeah.
Yeah.
Oh
Prove it.
oh bullshit! Exactly. So it goes through the testing and the licensing process. I believe in that process so much because I've been a part of it. I've done the audits. I've seen there's no secret conspiracy going on there, folks.
I would think if there's a secret conspiracy, it's against nuclear in the form of lobbying from these vastly lucrative, you know,
Mm, mhm, mhm,
other
mhm.
energy, solar and wind. I would think are
Yeah,
like
yeah.
let's put the brakes on this, boys. But
Yeah.
I, I mean, that's a conversation like this, and you being able to speak through all of this and from your experience, and just there's no hand waving here other than you having to dumb it down for me. It's like is it's so valuable for people to hear, and because this really, uh, I think this is the future eventually. Like
Yeah. Yeah.
that
We're
it
not going to
has
have a
to be.
choice. We're not going to have a choice. I mean,
Yeah.
I mean, even uranium is a finite resource. But again, go back and look at the power density. When I say you can run 18 months at full power, power cities for 18 months and then shut down and refuel, refueling is actually only removing 1/3 of the fuel assemblies and putting in a new third. Right. So you're not even every 18 months, you're only replacing a third. So you still have 2/3 of a tank, but you're stopping to refuel. Okay. And
That is insane.
there's a bunch of physics behind why we do that to keep a nice, even neutron flux that I mentioned so that these things kind of burn out completely and uniformly. Uh, Again, a lot of geometry, a lot of physics and geometry involved with that. But that's what keeps reactors stable is that we're very meticulous and very particular about how we run them.
It's just it's so and this is I would love to watch some actual animations of this and
Hmm.
just be able to see it, or even just I don't I'm sure, following people around in an environment like this when you don't actually understand the science is probably not as interesting because everything is closed off, but I would still like to see the inside of like
Yeah.
what one of
Yeah.
these places is looks like when it's actually running. It's so interesting.
Yeah. It kind of melted my brain. I'll be honest with you, man. I served 8 years in the Navy on 3 different boats. I had an image in my mind of what the scale was, right? Oh, that's a chill water pump. It's this big. If I had to, I could take the motor off that and carry the motor out of here. Then I went to a commercial plant, and the chill water pump that served the same purpose was bigger than my car, right? So it's like,
What?
oh shit, okay. That was an eye opener for me. It was like, okay, I gotta wrap my brain around the new scale of things because obviously, reactors you use on seagoing vessels, you try to keep that size pretty small and you try to keep them pretty compact. So when you
Well, and
move to a
even
commercial site, it's kind of wide.
yeah, and thinking too, oh, there are some that could fit in a semi trailer.
Hmm.
Like that's a small one.
Yep. Yep.
It's incredible, and it's I don't know. It is so interesting. So I know you've written a book. What does that tie into the coaching that you're doing?
Yeah, absolutely. The pursuit of identity and purpose was really written based not just on my own journey, but on my leadership journey as well. Um, Identity and purpose to me are pretty core in, you know, really living life intentionally, figuring out who you really are, what you really want to do. There's a long, sad, traumatic story behind why that's important to me, but there's some very important people in my life who um, suffered and ultimately took their own lives because they didn't think they had value. And from the outside looking in, they were amazing people, brilliant people, artistic people. They had a lot to offer, but because they measured themselves by a skewed set of metrics, they didn't achieve a certain title, they didn't make this much money, whatever the case was, it was heartbreaking to me. And I'll share with listeners, if you've ever done any work around your purpose or around your passion, I'm going to make a bold statement here and say, you did it wrong. I promise you, you did it wrong. And I'm going to share with everybody how and why. When I ask you, well, what's your purpose? What's your passion? Our mind automatically goes to all the things we love to do. Oh, my passion is skiing. My purpose is saving puppies, right? It's all this wonderful, flowery stuff. But the truth is, if you really want to know what your purpose is eradicating that thing that breaks your heart. That's your purpose. So if you want to do that work and you want to explore that, I definitely, I recommend go ahead, read my book. In fact, if you don't even want to do that and you're skeptical of that, I'll give you the first 4 chapters for free on my website. I really will. Just start to understand what that is. And, the thing that breaks my heart is people who don't believe they have value. So my leadership and my success professionally has been in developing people who didn't necessarily fit into that square hole. But I found a star-shaped hole, and there you go.
So I guess and this is obviously a face value. I disagree with that being that's what your purpose is. I think your purpose, which I think your value, your intrinsic value is derived from your purpose, which it sounds like you agree with based off of what you said. But why is it that removing as opposed to getting something that you're fulfilled from and doing something that is producing something, it's basically, like purpose to me, the way that I've always thought about it, and this is probably perfect for you to be able to to explain this, is it's something, it is a mission that I can get behind, and I will seek and pursue and do everything in my power to accomplish or work towards or, further progress regardless of what's going on around me, because I find that it is something worth giving my all to and committing myself to, and the hope of something larger occurring from it. For me, that's service to others. So I guess in that context, or how is that different slash off? I mean, to me, again, at face value, that seems very different from what you said.
That's exactly what I just said. So you and
Okay.
I are in complete alignment.
Okay.
So if you feel comfortable sharing it, what is your purpose?
Yeah.
Can you
So
summarize it to, yeah.
so I shot myself in the face 6 years ago.
Okay.
I'm completely blind now as a result of that. On one hand, it is, I've accomplished a lot since then. I rebuilt myself and had to relearn how to do literally everything from
Mhm. Mhm.
sitting up to peeing to feeding myself and brushing my teeth to where I am today. And part of it is sharing the insights and experiences that I've had in hopes that someone else hears it and realizes that the seemingly inescapable place that they're in is not inescapable and that there is another way out. And then in a like literal creation sense, the other half of that for me is I taught myself how to code since I lost my sight so that I can create software that is accessible to everyone,
Excellent.
regardless of whether or
Hmm.
not they have a disability. And so for me, it's decreasing these barriers that people with disabilities have and bringing them the same opportunities that everyone else has.
Okay. Okay. Is it fair to say then, if someone reached the same point that you reached and they were unfortunately successful, that would break your heart?
Yes.
Yeah. That's all I mean by that.
Oh,
So
okay.
here's the argument. Someone will come to me and say, "Oh, my purpose is cooking. I want to feed everybody." Okay. Imagine this scenario then. You just had a really long week. 5 days in a row, 12 hours a day, 60-hour week. You're getting, 5, 6 hours of sleep at night. You're completely exhausted. But finally, it's Friday night. You get home, do a few things, decompress a little bit, clean up, climb into bed. 3 hours later, the phone rings. The person on the other end says, "I'm hungry. Make me something to eat." What are you going to say? You're going to say, "Fuck no." Guess what? Take that exact same scenario, because that's my every week. 12 hours a day, 60 hours a week, exhausted, climb into bed. Someone who I'm coaching has a moment and they reach out to me 3 o'clock in the morning and say, "Charles, I need to talk to you."
Fuck no.
I say, "I'm going to take that call, Zach.
Yeah.
I'm going to take that call. I know we're goofing around. I know we're
Yeah.
goofing around, but I'm going to take that call." That's the difference between having an actual no shit purpose. You do not want that person to go through with that. I do not want that person to go through with that. I do not want anyone to feel like they're not valued, they're not important. Okay. So I always have energy and time to talk to people about that. That's what makes that my purpose. It is inexhaustible. I cannot coach too much. Do I get tired? Yes. Do I need to decompress? Yeah. Do I need to reset? Yes, absolutely. Of course. But I always have time to talk to one more person, to pull them back from the edge and say, no, 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 no. It's not you. You have purpose. No one has ever taken the time to show you how amazing your gifts are. You and your scenario, no, dude, that's not the answer. No matter how bleak it looks, that doesn't solve anything. All that does is take your fear and your pain and transfer it to the people who love and care about you the most. That does not solve that problem. That's the message you want for them. I guarantee that if someone called you up and wanted to have that conversation, I don't care how tired you are, you would have that conversation with them, because the thought of the alternative breaks your heart. Think about your purpose from that perspective. It'll change your fucking life.
Yeah. So your purpose is the act that diminishes or,
The
you know,
eradication. Yep.
gets rid of that. Okay.
Yep. Yep. Yep.
I like that, man. I really,
Good, good, good. Because you
yeah.
have purpose. You have purpose, and it's exactly, in my mind, how I described it. So,
Yeah, it does align with what you said. I totally misinterpreted that at first. I was like, what kind of bullshit is this?
I told you I am nothing if not coachable, and I love, you know. So I have an internal locus of control. I'm in charge of myself. I'm in charge. I'm very authentic. I have one identity, and so I'm very confident in myself. And it's not because I trick myself into it every day. I don't have a bunch of sticky notes all over my mirror, right? This is who I am, and I actually love and appreciate myself in a way that I never have before, because I stopped measuring myself against really shitty metrics. Albert Einstein has a really great quote that I will paraphrase, because I'll probably screw it up if I say I'm quoting him. But he had a really great quote that says, if you judge a goldfish by its ability to climb a tree, it will think it's worthless for its entire life. Okay. And that's what most of us are doing. We are goldfish, we are birds, we are elephants, and we're judging ourselves on, characteristics of a jaguar. Like, you're not that. Stop measuring yourself against that. You're missing your actual gifts and your actual value.
Yeah, and I think unfortunately, a lot of people struggle to find purpose. And I don't, I think part of that is maybe even not realizing that they are missing it. And that is, like you said, in trying to keep in line with this wrong framework that isn't a good fit for them of, okay, well, everyone else from my class is going to college, so I'm going to go to college. Well, I don't know what I want to do, so a business degree sounds safe. Okay. Now I'm selling paper and I fucking hate my job. Now I'm unhappy when I come home, so I treat people around me like shit, and that makes my
Um,
personal life shit. And it's
um,
it's a dangerous spiral.
Yeah. Yeah. I always say, I just had this conversation with my daughter. All bad behavior stems from fear. If you want to be able to dig down and find some empathy for someone, recognize that shitty behavior that they just displayed comes from fear. Try to understand what someone's fear is, and you'll have a much better chance at meeting them where they are.
Yeah, it's empathy is a hard one, man.
Mm.
It's something I think I've gotten heaps of it that I didn't have before I was blind since being blind. And some of that's probably getting older too. And being out of the Marines probably helps too.
Right. Right.
Right? There's no empathy in that environment. And like there's no room for it, right? Like
Right.
you need to be in a certain mindset there. But yeah, it is a powerful thing and still something that, I have to remind myself of a lot, but it's a valuable tool set to have, or, just aware again, of bringing it back to awareness, just being aware of that and like, okay, let's be a little more objective here and give someone some grace instead of
Yep.
just jumping to conclusions. But
But that's your emotional intelligence muscle. And unlike intelligent quotient, IQ, emotional intelligence can be learned. It can be developed. Absolutely. And, you can imagine the thousands of studies that have been performed on leadership and successful organizations. Every single one of them comes back and says one of the top two, top three requirements for a successful organization or a successful leader, emotional intelligence. It's common. It's known. It's not a secret. If you want to really excel and you want to be amazing at whatever it is you do, I don't care what industry it is. I don't care if you are entry level right now, develop your emotional intelligence. Do it. Do it now. I'm not saying don't pursue certifications. I have a freaking scrapbook full of certifications. I'm
It
not
sounds
saying
like it.
I'm not saying don't do that from a technical perspective, but don't think that your technical acumen is going to make you a good leader. It's not. Your technical acumen might make you a good manager, but it won't make you a good leader. The difference is absolutely 100%. It's emotional intelligence.
Yeah, and one is a resume bullet point, and versus the other is actually going to get the job done, and
Yep.
everyone will see that around you. Like
Right.
that's, but I mean, you do need both, but you can't ignore, or that's exactly the point. Is you do need both. But so what was the title of your book again?
The pursuit of identity and purpose.
Pursuit of Identity and Purpose. Very succinct and very fitting.
Yeah, yeah, yeah.
And where can people find that and you on your website to get in contact for coaching?
Yeah, I mean the paperback version's available on Amazon. Like I said, you can hit my website. I'll give you the first 4 of 12 chapters for free, and that website is therealcharlesbrowne.com. And it's Brown with an E, so I throw a little bit of a filter in there. But yeah, that's it. I mean, that's my home for everything I do. Or you can usually find me on YouTube or LinkedIn by looking for Charles Browne or Real C Brown or something to that effect. But
Okay. And I will have links to all that in the show notes as always for people at home. Do you have anything else you want to plug in there?
I just know not to plug except to tell everyone if no one has ever told you this before, you have value. You have value. Find someone that supports you and get after it.
You do. And if you're struggling right now, know that it is temporary and it's okay to not be okay, but it is not okay to not do anything about it. You have to speak up. Charles Browne, thank you for dumbing things down for me
Uh,
today and sharing all of that. I enjoyed this, and I'm so glad that this didn't just fall by the wayside with having to reschedule.
no, absolutely not. It was my pleasure, man. That was a fun talk.
Awesome. And thanks everyone at home for listening to another episode of Going In Blind. Remember, if you haven't already, please rate and review the show and then share this around with someone who needs to hear it. Maybe someone who hates nuclear energy. You get the idea. But we'll see you next week.